All right, so I'm going to assume that you've already seen my first video or that you already have some basic Linux knowledge. This video is going to be Linux networks, but practical. So I'm not going to be talking in depth about network concepts such as TCP, UDP, packets, all these sorts of things. If you want to see a video about these that explains them in more detail and that uses Linux commands to view how these things are happening in real time, just leave a comment or something, let me know, and maybe I can make that happen. Now, once again, timestamps are going to be shown on screen right now. Skip through whatever you're interested in, or if you want to watch the whole video, if you're new to this, then I would suggest that. But yeah, otherwise, let's get started. All right, so let's talk about the environment. If you want to follow along, you will need to have access to at least 2 Linux servers or environments. There's 3 ways that you can do this. Number 1, using a Docker file. If you are coming from the Discord server, I will have attached a Docker file with all of the configurations and all the packages already pre-installed so that you can follow along. You just make 2 versions of, or 2 containers using this Docker file, and you should be good to go. Number 2 is using AWS. I personally recommend getting very acquainted and familiar with AWS because you're most likely going to be using it or other cloud providers sometime in your career. If it's your first time using AWS and making an AWS account, this is going to be completely free because AWS provides you with 200 free credits for your first 6 months that you make your account, I believe. So you're not going to be paying anything. If it's not your first time making an AWS account, you will have to pay a few cents. I believe it's something like every 100 hours or 200 hours that you have these servers running, you will be paying $1. So again, that's $1 per 200 hours. So that's a pretty good deal, I think. Now, the third option, you're going to have to do a little bit of research yourself, but I do know that there are free, I think, free Linux environments that you can use online. Again, you're going to have to do a little bit of research here. I know that they exist, but I don't know any off the top of my head. But yeah, so in this video, I'm going to show you everything using both the Docker approach and also the AWS approach. If you're not coming from the Discord server, I will also show you the Docker file so that you can create it for yourself and follow along that way if you want. But yeah, let's get started. All right, so let's set this up for Docker. So as I said, if you're coming from the Discord server, all you have to do is download it and navigate to whichever directory it is in. For everybody not in the Discord server, here's the Docker file that you can copy. Just pause the video and copy it and then run the following commands. So again, you're going to want to navigate to whichever directory the Docker file is in, after which you want to run these commands. So first, docker network create Linux network. Number 2, you're going to want to do a docker build -t Linux network and a dot at the end, sorry. Now, this is going to take like a minute and a half or 2 minutes for you, but I already did it, so it's taking very little for me. Lastly, you want to do a docker run -it -network, oops, -network, Linux network, -name client, and Linux network, just like this. Now you'll notice that you have a student and a random hash. If you want to triple check that you did this correctly, you can do a cat/etc/os release and see that the name is Ubuntu. Now, the last thing that we need to do is open up a second terminal. Once again, navigate to whatever directory your Docker file is in and run the exact same final command we just did here. So paste it here, except now the name is going to be server. Just like this, run, and once again, we can do cat/etc/os release to double check, and we see that the name is Ubuntu. So that's all you have to do. Okay, so now let's set this up using AWS. So if you don't have an account, you want to go to this website, aws.amazon.com, and hit create account. Once you create your account, you might see something like this. So if this is the case, all you have to do is select root user and then sign in with your sign-in credentials. Once you are in, you're going to see something like this. Now, you're not going to have anything here or anything here, but that's all right. All we're going to do is go to the search bar up here and type in EC2. This is the name of a virtual machine that you can rent out from Amazon, basically, okay? Once we're here, you just want to hit launch instance. If you don't see this page, or if you instead see this page, once again, just launch instance. And you're going to call, the first one is going to be client, and we're going to select Ubuntu. You're going to scroll down a little bit. Instance type is going to be T2 Nano, or whatever the top option is for you. Okay. And lastly, key pair, we're going to create a new key pair, and we're going to call it Linux network. This name really doesn't matter, but I'm just going to call it that. You don't have to change anything else. Create key pair. You're going to see that this is going to download it to your computer, and we're going to make sure that you know where this is downloaded. I know where it is, so I'm not going to show you, but because I don't want to dox myself, but just know where it is. And lastly, all you have to do is enable HTTP traffic from the internet. Okay, so make sure you have SSH and HTTP. We're going to talk about all of these in a second. And yeah, all you have to do is launch instance. There you go. However, in my case, I'm going to do 2 instances because I want to have 1 client and 1 server. So we're going to launch 2 of them. It's going to take a second. And then we will see here we have successfully launched 2 of them. And we can click our instances here, and there should be 2. Both of them are called the client. We'll just rename one to be server. There we go. And then we're good to go. Okay, that's all you need. Again, just remember where that key was installed, okay? Because we're going to be needing this to connect to both of these. But yeah, you're good. One final note is that you can actually mix and match these Linux environments. So for example, if you want to use one Docker file and connect it to AWS, this is what you have to do. So we need a way to move this .pem file into your Docker container. Now I'm going to talk about what a PEM file is, so don't worry, but we need a way to move it in the container so that the container can connect to your Amazon servers. So the way we're going to do this is by using the following command. So docker cp to copy my Linux network PEM file into the name of the Docker container. Now, if you remember, when we created the Docker containers, we named them client and server. So that's exactly what we're going to do. We're going to do client first, :/home/student/. And the way I got this is, so client is the name of the container. Okay? And then this is the directory that I want to copy it to. So you'll notice if I do pwd, I'm inside /home/student for both of them. So if you want to move it to this directory, you have to do the name of the container and then the directory that you want to copy it to. So I'm going to run this, successfully copied. And then if we run ls, we see that we have linuxnetwork.pem, but here we don't have it because this container is the server. So we need to run the same command, but called server. Okay, I hope this makes sense. And if we do ls again, we have the PEM file in both. Okay, this is only if you're using one Docker container and you want to connect it to AWS. Okay, that's all. Okay, so now let's actually start talking about Linux networking. So the way I like to think about this is that, let's say you have a friend and you want to talk to your friend in the 1900s, okay? So you would have to go to their location. You have to, let's say they live in a hotel. So you would have to go to their hotel and talk to them. So how would you do this? First, you need to know where they live. So you would need the address of the hotel, and then you would need the room number that he is in, so you can go and talk to him, right? So similarly, computers need a way to identify which computer to send data to. And you can't communicate if you don't know the address. So that's why we have IP addresses, which is like the street address of the hotel. Okay, so this tells you the location of the computer, or like the address of the computer. And you have a port, which is like the room number in the hotel. So ports allow you to specify which app to send your request to, because multiple apps need separate ports. Okay, so one port per app. So I hope this makes sense. We understand where to send the information to now, right? Because we have IPs and ports that tells us exactly where to send the information. But now we need to think about, how are we going to send it, right? Because just knowing the address and knowing the port is not going to actually deliver the message for us. Okay, so now let's say that we don't actually want to go to our friend's house because we're lazy, but we still want to send them the message. So how would we do this in the 1900s? Well, we would send mail, right? So the mail is just going to contain the letter that we want to provide them. Or in the case of computers, we have packets, which are like mail, okay? So we have packets, and the packets have content inside them with the message that we want to deliver, okay? Now, just like mail, which has key information such as the sender's address, the receiver's address, and also any other information like the content itself, packets themselves also have these key information. So such as the source IP, the source port, and the destination IP, destination port, a little bit of more information, and then the actual content that you want to send. Now, let's say that instead of sending a mail, or instead of sending a normal content of a letter, for example, you want to send a book, and the book has 1,000 pages, so it's a really thick book. Obviously, this doesn't fit inside mail. So what you're going to do is that you're going to cut the book into small little pieces, maybe like 10 pages, okay? And you're going to put 10 pages inside of mail. So you're going to have 100 different mails that you're going to send to your friend, okay? Similarly, this is how packets work. So if you're going to send a large amount of content over the internet, a packet doesn't contain all of that content in the same packet. It's actually going to break up the content that you want to send into hundreds or thousands of different packets, and it's going to send them all to the destination IP and port, okay? So those are packets. All right, so now we know our friend's address. We have put all of our messages into packets or into mail, but now there's another problem, which is we can send packets or we can send mail to and from our friend, right? But they don't really have reliability. They don't really have a structure or rules. So for example, imagine mailing a letter, but not getting confirmation that it actually arrived, or mailing the letter and then having no way to know if it was lost, and if it was lost, it doesn't automatically send a new one. Or, for example, you're sending that massive book that I mentioned, except the other person, your friend, doesn't receive them in order. How can we guarantee that it's received in order? How do we check if the mail was opened before it reached the friend so we can avoid corruption? All these sorts of things. So for this, we created transport protocols, okay? So there's two of them that are kind of the foundational ones, and one of them is called TCP and one of them is called UDP. I'm not going to go too into detail. Just know that generally, TCP is reliable, ordered, and connection-based. What does that mean? That means that TCP is going to solve the issue of packet losses because it's automatically going to send packets that were lost. It's going to guarantee packet ordering, so your book is going to arrive in order. As I said, it has retry rules, so if packets are lost, it's going to retry those specific packets. It has other functionalities like flow control and data integrity to prevent against corruption, and it also requires a connection to be in place. And we're going to talk about this maybe in a different video because I don't want to go too into depth, but TCP, just remember, is reliable, ordered, and connection-based. Now, UDP is sort of similar, except it's kind of like you're going to send your packets and just forget about them and like hope for the best. So it's simple, it's faster than TCP, but it is super unreliable. Now that might not matter. For example, if you're streaming a video or you're streaming a TV show or you're playing games online, let's say one packet is one frame. You don't need to see every frame to still play your game or to understand the video that you're watching. So it's okay to lose a few packets. And in this sort of situation is where UDP is the go-to. All right, so now we know about transfer protocols, which allow us to safely and reliably send packets to and from destinations, right? But now we have one more issue, and that is, what do the packets, what do the contents inside the packets actually represent? In the case of mail, you might be sending mail to several people around the world, and everybody has their own different language, right? You can be sending mail to somebody in China, India, US, anywhere, right? So we need a standardized way or a standardized language that the letter inside the mail speaks or is written in so that everybody understands what's going on. Similarly, we need a standard way to ask for resources, a standard format for the messages, and kind of like a universal method for browsers, servers, APIs, and programs in the software world. So that's where HTTP and HTTPS comes in. So HTTP is kind of a language on top of TCP that defines what a request looks like, what a response looks like. It defines different content types and a URL structure that we can use. And this might not make sense immediately, but this has a little bit more to do with APIs and generally how the internet works. But yeah, just understand that it's built on top of TCP, and it defines a schema that all of these TCP packets or packets sent through TCP can speak so everybody universally understands one another. HTTPS is the same as HTTP, but it is encrypted, okay? So I'm not going to go into too much detail there either, but it's encrypted, it's safer. Now, there's one more thing that we have to talk about regarding HTTP and HTTPS, and that is in regards to ports. Now, the reason I bring this up is because let's imagine, or actually, we know that different software need different ports, right? So one port per app, that's actually not a requirement, but it just makes things easier to visualize, okay? So each app has its own port running on the same machine, which has an IP address. But the thing is that if everybody uses different ports randomly for the same protocol, nothing would work because, for example, I'm going to send HTTP traffic to a specific IP on port 200, except that IP address is listening for HTTP traffic on port 100, let's say, because everybody's ports are randomly assigned. So as you can see, this would be problematic, nothing would really work. So the internet community as a whole agreed on well-known ports for common services. So for example, HTTP will always be sent to port 80. So whenever we send an HTTP request, we can just expect to send it to port 80 and it's going to go through. Same with HTTPS, it's always going to be sent to port 443. There's a few other protocols we'll go through in this video, except the most important ones for sure is HTTP is port 80 and HTTPS is 443. Okay, so one last thing we have to talk about before we get started with the commands is DNS. And the best way to understand this, I think, is by going through this example. So let's say right now I want to go to Pokemon's website. Okay, so I want to go to the Pokemon website. And as we talked about, when you make a request to anything in the internet, you need an IP address and a port. Okay, so I'm going to search up http://. By doing HTTP here, what we're doing is we're specifying port 80, because as you recall, whenever you type in HTTP, this implies that you're going to send a request to port 80, okay? And then we need the IP address of whatever we want to access. So I wanted to access Pokemon, so I'm going to put in the IP address of Pokemon servers. And then would you look at that, we're on Pokemon's website. But you might be thinking, you've never done this in your life. You've never had to put an IP address in the URL bar and then hit search and Pokemon appears. What you do instead is you just search up Pokemon, right, .com, let's say, and then it takes you to the website and it's the exact same thing. So what is actually going on here? This is what DNS does. DNS translates a name that you put in here. So for example, Pokemon.com again, it's going to translate this into an IP address, which in this case is this IP. That's all you have to know about DNS. There's a lot more information on DNS that on how it works and what's happening behind the scenes. But again, this is just like high level overview because this is practical Linux. Okay. You might also be wondering how I got this IP address, and we will talk about that. I will show you in this video how you can find this out. And anyway, yeah, if you don't understand some of the things we talked about right now, no worries. Perhaps all you have to do is follow along, and you'll be able to see how things are working at a lower level in real time. So hopefully that's going to help. All right, so we're finally ready to start learning some Linux commands and seeing how all of this knowledge is happening behind the scenes. So first thing we're going to learn is called netcat, or NC for short. Now, what this command does is set up a very basic connection in TCP or UDP protocol. Okay, so the first argument is going to be the name of the domain that you want to connect to. In my case, I want to connect to example.com. The next argument is going to be the port that you want to connect to. Now remember, as I said, HTTP requests are always going to connect on port 80, and so we have to specify port 80 here. Now what we're going to do is actually search up example.com and see what it looks like. So as you can see, we have only a header, and we have a paragraph. This domain is for use in documentation examples. Okay, so let's go back to our terminal and let's run this command. Nothing happens. So stuff is actually happening behind the scenes, but we can't see it because we haven't used the verbose flag. So I'm going to add a flag -v. This means verbose, which is going to show more information. So if we run it again, we see that the connection to example.com, which is actually living in this IP address, and this was obtained using DNS, remember that, on port 80, succeeded. And here we see TCP. Okay? HTTP, again, is built on TCP, and that's why it's showing both. Okay, so TCP is like the lower level language. But you still see we didn't really get anything in return. It says connection succeeded, but we haven't actually sent anything yet. So what we're going to do now is actually send some content to the server. Okay, and the way we're going to do that is by, oh, timeout. Excellent. So let's try this again. And let's actually run a request now. So I'm going to send an HTTP request, and this is what it looks like. HTTP, and you don't have to know this, but I'm just going to show it to you so you can see it. Just like this, and then I'm going to do host. So the host or the server that we're trying to connect to is example.com. And HTTP requests require one line in between the headers, which are what these are called, and the content, which we don't have any, so we're just going to press enter again, and we see the response here. So we see the response is HTTP, status code 200, OK, content type text or HTML, some more information, and then here's the actual content. And what is the content? It is text HTML. And we can see here that it says doc type HTML. So this is actually an HTML content that we're receiving here. And let's look, here's the paragraph. This domain is used for documentation examples, yada, yada. And it also has a learn more button. So if we go back to the site itself, it's exactly the same thing that we got here and the learn more button. So it's exactly the same information. And so again, what we did is we used netcat to create a TCP connection to example.com servers, which is resolved to this IP address using DNS, which happens behind the scenes without us having to do anything. On port 80, and again, we're using port 80 because HTTP requests require sending it through port 80. So that's why we need port 80 here. We can see that it picked up that it was in fact an HTTP request. And again, HTTP is using TCP in the background, which is why it shows this, and it succeeded. After that, we need to send the actual request because all we did initially is just connect to it. So we send the request by doing a GET request. Now this has to do with APIs, so I'm not going to get into details here. And you don't have to understand this because there's another command that does the request for you. So we'll see that immediately after this, but just know that this is an API request, okay? So we're doing get, you don't have to understand this, to host example.com, and we need 2 spaces. Again, you don't have to understand this right now, but just know that we sent an HTTP request. And now this is the response. So you got an HTTP 200 response code, okay? We'll talk about response codes in a second here. The content type is text HTML. We get some more information, and then here we actually see the text HTML that was returned, which is exactly the same thing that we see when we run it through Google. So you might start thinking now that Google, when you send something like this, when you put something on the URL, the only thing that's happening is an HTTP request in the background, and you would be correct. This is exactly what Google is doing in the background, okay? But typically, instead of HTTP, it uses HTTPS because it's encrypted, but it's the same idea, okay? And we'll see what that looks like in more details soon. Okay, so now we know how to make an HTTP request through TCP using the netcat command, right? Which is what we just did. But again, as you can see, it's kind of a pain, like, to have to write all of this every single time, especially since it's exactly the same thing every time. The only thing that changes is maybe the name of the domain that you're interested in. So there's actually another command that does this part for you, and that's called curl. So if we use the curl command, and we do the same thing, so example.com, this time instead of doing port 80 like this, we have to do port 80 after a colon, so example.com :80, and we run this, we see we get exactly the same content. So doc type HTML, exactly the same thing that we did with the netcat command. If you want to see more details, again, we can use the verbose flag, so -v, and we get pretty much exactly the same content. So arrow to the right or greater than is showing sent, and arrow to the left or less than is showing received. So what we sent is get/HTTP 1.1, exactly the same thing we did here, to a host example.com, and a little bit more information that's not exactly required for the request. And then what did we receive? Exactly the same thing as with the netcat command. So you can see with, again, a little bit more information, but we still get content type HTML and more of this, right? Now, I want to point out that the first line here says trying 23.192, et cetera, and you can see that this is the same IP that shows up here. So this is kind of an unfortunate example because it's a little different than this IP up here, but this is the IP of example.com. And you might be wondering where or how does this happen? So again, this is done by DNS, but we can actually verify which IP addresses are associated with example.com. And this can be done using the dig command. So if you dig example.com, we can see there's multiple IP addresses that contain the example.com. Okay. Now you might be wondering what is all this information? Number one, what is this number? What is an A? Why are there multiple IP addresses? This is a little bit more advanced stuff. I just wanted to point out to you that if you use the dig command, you can actually find out which IP addresses are returned by DNS. So you'll notice here that the DNS returned, let's see, where is it here? 23.192, right? On port 80. So if we search for this, just like that, we see that it was returned as part of this DNS query, okay? Again, you don't have to worry about what any of this is. This is beyond the scope of this video, but I just wanted to show you how you can check the IP addresses of domain names, okay? That's all. So now we know how to make a request using netcat. We know how to make a request using curl, but there's actually a lot more you can do with netcat because it's as I said, simply it's just creating a connection between a client, which is wherever you're sending the request from, and a server, which is whoever is receiving that request. And I'm going to show that now. All right, so we know how to use the netcat command, but let's actually try to connect between our Docker containers here. So if you're using AWS, you can follow along, but if you're doing a combination of Docker for one of the Linux environments and AWS for another, this is going to require a little bit more. I'm going to show you first how to do this on Docker, and I'm going to show you how to do it on AWS, and then later you will have enough knowledge using another command that's going to be later in the video to do this using the hybrid method, okay? But first, let's do Docker. So we know that we have to use the netcat command, but next is the server, okay? The name of the server. So if you recall, when we created these two containers, on the left side here, we did docker run --name client, and on the right side, we did docker run --name server. So that means that the name of this container is server. So we can do that here. So the name is server on port 80 to make an HTTP request. Now I'm going to add the verbose flag here so that we can see more information, and let's see what happens. So connection refused. Now, the reason for this is because port 80 is not open on the server, okay? And we can verify this by running the ss command. So the ss command is used to list out ports in your machine, okay? So specifically, we can take a few flags to specify that to be listen only to TCP ports, or sorry, list all TCP ports. So those are ports that are accepting TCP connections. And we're gonna further filter that to only show ports that are open to TCP connections and that are listening. So they are open to receive information, okay? So if we run this, we only see that we only have one port that is in the listening state, and that is port 36,793, okay? I'm not sure what this is, but you can see that there is no port 80, okay? That's the point. So to open port 80, we can actually use the netcat command as well, and we can do this by doing netcat listen on port 80. So we're gonna open port 80 to be listening. Now, if we do this, and we run the same command, we'll see that the connection succeeded. So now we have a connection between the client and the server. And now if I send any information on the client, so like, hi, it's going to show up on the server. And again, this is because we made the connection, and now anything that is sent on the client is going to end up on the server, and anything sent on the server is going to end up on the client, just like this, okay? So this is, we literally made like a chat, basically, is what we just did. And again, this is working through TCP, as you can see here, okay? If I were to do the ss command again, you would be able to see port 80, and I'll show you that now. All right, so let's get into this container from another terminal. So what we're going to do first is we have to list out all of our Docker running containers, and we can do that by doing docker ps. So you'll see we have a server and a client container, okay? Now what we're going to do is we're trying to connect to the server, so we're going to copy this container ID and do docker exec -it this ID, and then we're going to just do bash. And now you'll see we're in the same container, and we know because it has the same hash section, okay, the random ID. So now if we do ss-tl to list all of the TCP listening ports, we'll see that we have another one on HTTP, okay, it's listening on HTTP. Now this doesn't tell you the port, but we can get that through doing the n flag. So n is going to say, do not replace the port numbers with names. So instead of getting HTTP, we're going to get 80. And that's exactly what we see here. So we're listening on the current IP address on port 80, and it's listening, okay? And that's because we have this. Now you'll notice if we close this connection, or we stop listening on port 80 and we run the same thing, we no longer have port 80 that is listening. So that's pretty cool. Also, one more thing, you can run the verbose flag here as well. And he says listening on the current IP, which is what this means, on port 80. So now this is no longer going to work because we closed the connection. But now if we run the same command, you'll see that connection received on client.linux network, and this shows up because we're using a Linux network for Docker. Don't worry about it. And then the port that we received the connection from is 40,000, which means we're going to talk about this port a little bit later, but don't worry about it right now. But again, here, if we run the same command, we see that again, we have port 80 listening on TCP, okay? Okay, so now let's do the same thing, but on AWS. Even if you already did this on Docker, I still think it's a good idea to see how this is working on AWS because it's exactly the same thing, except without using Docker networks, which is not what you're likely to be using in the real world. So let's do it through AWS now. So first I'm going to click my instance ID here for the server. You'll see here that it says server here, so that's how we know where we are, and we can do connect. We just leave everything as is and just hit connect as well. And we're going to do the same thing, but for the client. So once again, instance ID, open the new tab, it says client, and we're going to do connect again. And these are going to be, it's just going to open a terminal session on these servers. Okay, so here's the server. We can see that down here. And here's the client. So I'm going to try to connect to the server. So again, netcat, and then the IP or the name of our server. Since we don't have a name, we're going to use the public IP, which is right here, just like this. And then the port number 80. And oh, let's see, -v for verbose, and it says connection refused. Wonderful. So this is a little bit of a different error, but we can just open a port here and see what's going on. So listen on port 80, permission denied because we need to be using sudo. That makes sense. And now listening on our local IP on port 80. So if you run this again, succeeded, and now we can just run like I love Linux, and we should expect it to be showing up here, which it is. And then once again, let's duplicate this on the server. So I'm just duplicating the server. And the reason for that is because we can check the open ports using exactly the same thing. So SS, I'm going to look for TCP connections that are listening, just like this. And we should see, without turning, I mean, here you can see HTTP and a few others. We'll talk about SSH, but yeah, without turning these names, or without turning the numbers into names. And here we can see port 80. Now, if you remember from the first video, we can actually do a grep port 80, and this is going to show us the port 80. This is like a control F, command F, if you remember. So anyway, this is another cool use for grep. But anyway, just so you see how this is done. Now, in the real world, you're most likely going to know what the IPs are for everything. So if you set up these servers yourself, obviously you can see the IP addresses. But if you're joining a company and you have to do work in that company by connecting to servers, which is very likely, then they will give you, like, in some way, you will have access and you will be in the know of which IPs to connect to. Okay, so don't worry about how to find out what your IP is and stuff like that. There is a command called IP adder, and it shows you what your IP is. But however, this is going to show your private IP. This is something else. So don't worry about this. I just wanted to tell you that typically when working with remote servers, you will know the IPs. Okay. Now, one more thing regarding Netcat, I just want to show you how versatile it is. Netcat has a lot of options, but one of them is that we can give a predefined response to whoever connects to Netcat. So for example, we can do an echo command, right? Let's do hello world. And we know what this does from the first video. It just prints the std out. But we can redirect this to be the std in to the next command, right? So the next command is going to be sudo netcat listen on port 80. So what this is going to do is that it's going to listen on port 80 as a TCP port, right? And then, because TCP is by default, and then anything that connects is going to receive immediately hello world. So we're going to run this and we're going to connect to it from locally, just to give you an example that this doesn't only work between AWS services, but since it's through the network, as long as you have internet connection, you can do this from anywhere. So netcat, again, we're going to take this IP here, just like this, and then on port 80. And yeah, let's see what happens. Let's do verbose as well. Verbose. There we go. Connected to port, succeeded, and then we get hello world immediately, which is exactly what we said to happen here. So the point of this is to show you that netcat is very, very versatile. If you do netcat-help, I believe, or --help, yeah, there's, as you can see, there's a lot of options, and there's even more if you check out the man pages. But anyway, point is, netcat is a super useful tool, and yeah, let's move on to the other tools. All right, so next, let's talk about what I think is one of the most important Linux commands, and that is SSH. SSH stands for Secure Shell, and it allows you to connect remotely to another Linux device and open a shell securely, so that is encrypted, okay? So what this allows you to do is run terminal commands remotely on a different machine. And I'm going to demonstrate first using Docker. Before we start, though, I'm going to do an ss-tln, and that's going to show you, again, the open ports that are listening. That's a TCP port, and without translating port numbers to names. So if we do this, we only have one, okay? Now, if we run this command, sudo service ssh start, it says secure shell server sshd has now started, right? So if we do ss-tln again, we see that we have two new entries here, and they're both on port 22. We'll talk about what these mean in a second. And if we remove the n flag, we'll see that it's for SSH, okay? So what does this mean? I'm going to just show you, and hopefully you'll be able to see what's going on. So I'm going to do an ls just so you can see what's going on. I have two files, one pem and one sample file.txt. So what I'm going to do is SSH as a student. So, and the reason I'm doing student is because here, the user I'm logged in as is student. So I'm going to log in as student at the following IP or the server. So in this case, the server name is server. Okay. I hope this makes a little bit of sense. And all we just do is enter. So this is going to say authenticity can't be established. The key is not known for other names. This is a security measure that basically says, hey, this server you're trying to connect to has not been connected on your device before. Are you sure you want to continue? So you can do yes. And then there we go, permanently added server to the list of known hosts, and enter the password for student at server. And if you're using my Docker files and if you copied it, this is going to be student. So just input student there, and then there we go. We are now remotely connected to this machine. And I can prove that by doing touch. So we're going to create a new file, and it's going to be called test, or no, actually, I think, oh no, we don't have a test, so test.txt, just like this. And now we do ls here, and we see that we have a test.txt. So I hope this makes sense that like we are remotely connected from this container into this container and are able to run commands remotely. If we do the same thing here, we get the same output. Okay, so another way we can actually quadruple check that we are in fact using the same machine as this, like connected to it, is that this ID matches this ID. Okay. Okay, cool. Now to exit this connection or to end the connection, we just type exit, and the ID is different now because we're back at our client and this is the server. Okay, so they have different IDs. Now, every time you want to connect to the server, you're going to have to do the same command, right? SSH student at server, student at server. And this is fine because this command is relatively short for us, but sometimes this server name can get pretty long, or sometimes it's an IP address and you don't want to remember the IP address. Like the point is, you can actually make this shorter. You can do what an alias does, but for SSH. And if you recall, an alias is just like alias LL. You can set a specific, your own custom command to do a specific actual Linux command, if that makes sense. So let's do the same thing for SSH. Now, the first time you make a connection, you're actually going to see that there's a .ssh directory that gets made in your home directory. So that's the tilde here. And let's investigate what's inside. And you'll see that there's a known host and known hosts.old. We're not going to talk about those. That's more in depth on SSH. But what we can do is make a config file in here. So that's what we're going to do. .ssh config. And inside this config, again, don't follow along if you don't know Vim. There's a way to do this with printf command. But if you're not familiar with C or C++, it's, I don't know, I just don't want to get into it right now. But there is a way you can do it. Just ask ChatGPT how to use printf command. But anyway, I'm going to use Vim here. And I'm going to specify what the shortcut name is going to be. So the host, so the shortcut name is going to be called, like, I don't know, maybe Docker host, because we're using Docker. Now, the actual host name is going to be server. And the user that we're trying to log in as is student. And again, that comes from this right here. Okay? So we're going to save that and exit. And now if we try to SSH by just typing, actually, I just forgot what we did. Silly me, Docker host. So if we do SSH Docker host, just like this, you see we get student at server's password. So I'm just going to type in student. And again, the reason we get this password is because we're trying to log in as student, and student has a password set for it. So that's why we're getting this. So we just type in student as the password, we hit enter, and now we're in the same environment that we were in before, except this time we don't have to remember any IPs or anything at all. We just do SSH Docker host, okay? And again, that's because we edited the config file. So I hope that makes sense. Docker host is the shortcut, and we're actually connecting to the server using the student user, okay? So that's pretty cool. Okay, so now we know how to connect using SSH, but there's actually one more thing that we're missing, and that is SSH security. So we already know that depending on the user you're trying to connect as, it might ask you for the password to log in into that user. But to increase security, SSH itself actually does a password check while you run the SSH command. So before you even try to connect to the device. And this password, if you pass, it means that you do have authentication. You are authorized to connect to this server. But if you don't pass, if it's not the right password or a key or whatever it is, then you're not authenticated to connect. And if you recall, when we first created these two Amazon instances, and if you didn't do this, you don't have to worry about it. Just watch what I'm doing. When we first created them, I did mention that you wanted to save this .pem file that was installed, right? And you wanted to save it somewhere on your device and remember where it was. And this is where it comes in. So a .pem file is actually a key that you can use to log in or to authorize, validates that you are in fact able and allowed to connect to a server. So we're gonna add this to our Docker file. If you want to add it to your Docker file, you just do Docker. Actually, first we need to identify where we want to copy it. So Docker PS. I want to do it to my client just because it doesn't really matter. So I'm going to do Docker copy Linux network pen into here at the specific directory. So I'm going to do /home/student/ just like this. Oh, that's my bad. It's colon and then slash, just like this. So now If we do ls in here, we see we have a Linux network.pem, and now we can connect to our AWS server. So we're going to do the same thing, SSH. Let's go look at our server again. This is our public IP, and our username is Ubuntu. So we're going to do Ubuntu at this IP. And we're actually missing here a identity file. So again, this file is going to have a key that shows that we are in fact able and allowed to connect. So I'm just going to do Linux network, which is the name of the file. So again, what this is saying, we're doing the normal SSH command as Ubuntu to this server, except we're going to use an identity file called Linux network.pem. And I'll show you this, what it has in a second. But if we try this, the authenticity can't be established again because we're making a new connection. We do yes, and then we see unprotected private key. So it is required that your private key files are not accessible by others. And if we do ls-la, we will see that our private key here, where is it, Linux network.pem, is actually readable by other groups and by others in general. So let's remove that. So this is using the chmod command, which we again covered in the first video, and we're going to set the permissions to 500 for Linux network. So if we do ls-la again, we see that we have read and execute. We don't even need execute, so actually we can just do chmod 400. That's my bad. But yeah, anyway, so now as you can see, we only have read privileges. Okay, and if we try to do the same SSH command again, so SSH, let's gonna do this, SSH-I, Linux, Ubuntu, all that stuff. Now we are actually in, okay, which I think is pretty cool. And you see we have Ubuntu at IP, whatever this is. So I'm gonna go back to my browser and I'm gonna double check that it is in fact the same. And as you can see, it does match. So we are now remotely connected. Let's ls to make sure we don't have anything. We go back here. I don't know, let's do a touch test. And then we go back here and do another ls, and there is test. So we know how to SSH with and without identity files, and we know how to SSH where the user requires a, where the user requires a password as well, okay? And this is what an identity file looks like. Let's see. I think it was called Linux. Oh, sorry, I'm in the wrong. So again, exit to end the connection. Let's see what it's called, Linux network. So I'm going to cat Linux network. This is what it looks like. Normally, you don't want to show this at all, but I'm going to delete it as soon as I'm done making this video, so that's why I'm fine with showing it. But this is what a key looks like. Okay, it's just a bunch of random characters that are used for encryption. Okay, but yeah, that's identity files. All right, so now we know all about how SSH works. There are more options, but that's just the basics. But now let's say you want to copy files over from your local machine to the remote server, and we can actually do this using the sftp command. So sftp, this stands for secure copy. So we already knew about the copy command, which is cp. But this one is secure because it's over the network, and under the hood, it's actually just using SSH for the connection, okay? So what we're going to do is, same as the copy command, we're going to need a file that we want to copy. So I'm going to copy this Docker file, okay? So scp, Docker file, and we're going to copy it to the remote server. So again, it's called Ubuntu. That's who we're trying to log in as at this IP address, okay? And we want to copy it to a specific directory. So I'm going to go to my Firefox here. What is my present working directory, /home/Ubuntu. So I'm going to copy this and just put it here. Okay. So if we try to do this, are you sure you want to connect? Yes. But permission denied public key. Okay. This is what it looks like when you try to connect to a server without an identity file when it requires an identity file. So as you can see here, when we did the ls right up here, we do also have the Linux network PEM, which is the same one that we need to use. So let's try running the same command, but again, we do -i for identity file, sorry, -i, and then the name of the file, which is linuxnetwork.pem. And if we do this now, once again, unprotected private key, we know how to fix this. And again, this is because everybody has read privileges, which is unsafe. So we can do a chmod 400 for Linux network. We check again, we only have read privileges for the owner of the file, which is us. So that's perfect. And then if we run the same command, we are now in. So there you go, Docker file, 100%, it was uploaded. And now if we do an ls here, we now have the Docker file, and it has the exact same contents that we had in our local machine, which I think is pretty awesome. Okay, now we can also transfer directories. So once again, let's see what we have. We have Golang, which is a directory. So let's transfer that. Now the only difference that directories require is that we need the R flag. So scp-r for recursive, so it's going to copy everything inside of the directory, and then everything else remains the same. Except now, instead of Docker file, we want to do Golang, which is the name of the folder. Okay, there you go. We run this again, and now it's going to copy all of the files inside of this directory to that server. So let's check ls, and there is Golang, and if we do an ls in Golang, we can see that we in fact have the 3 files that we copied over, which is exactly what we wanted. So that's great. That's amazing. And that's SCP, secure copy. All right, so we know how to use SCP, but there's a few drawbacks to using SCP, and they're not necessarily issues with the command, but more so things like, for example, what if we want to have a more interactive and a simpler way to transfer files to and from our machines, right? So for example, right now, if we run the same sftp command, what's going to happen is that, let's see here, sorry. Okay, so this means the same one we just ran, right? We're going to copy our local Docker file into this remote server at this directory. But what happens if we want to flip this? So instead we want to copy from the remote directory to our local machine. So the way we would do that is first put the remote machine, right? And specifically we want the Docker file, and then we want to copy it in our current directory. So that's what the / means, okay? So if we run this, that works, and so that's fine, except you can see that it took a little bit of rearranging the command, and sometimes we don't want this. We want it to be easier, right? Another thing is that the scp command has a few, its implementation changes slightly between Linux distributions, okay? So this might cause unexpected errors or just like weird behavior with scp. And one of the biggest issues is that it's hard to transfer multiple files. You can do it, but it's a little restrictive. It doesn't really let you do filters. It just has a lot of, I don't know, not very convenient things. Okay, so it's great for single file transfers, targeted file transfers, but not really great otherwise outside of that. So to solve this, we can use sftp command, and this stands for Secure File Transfer Protocol. Okay, so it is a protocol, but let's just see it in action. So Linux network.pem, we already know how to do this, except now we're just going to give it the server by itself. So we know that it's this, so I'm going to put it there. And as we can see, this is going to put us in an interactive shell, okay, or an interactive subsystem for interactive file transfers. And what I mean by that is, for example, let's run ls. We see that ls is actually not giving us the same output as running ls on my local machine. And that's because this ls is actually reading off of my connected server. So if we do ls here, we see Docker file, which is exactly the same thing. If we do pwd, it's reading from the remote pwd. So if we do pwd here, it's the same thing. And if we want to read it from our local machine, then we do local ls. So here we can see we actually get the same output, or we do local pwd, and again, we see the same directory that I'm currently in. So why do we need this? Because it allows us to be more interactive. So for example, let's say I wanted to upload my test file, which is in my local machine, into the remote server. So what I can do is simply do put test, and that's it. Literally just 2 words. So put test, and it's going to upload it to the remote machine. So now if I do ls, which again is the ls on the remote machine, we see that we have test. What if instead I want to retrieve files, so copy them from the remote machine to my local machine? All I have to do is get, for example, Docker file. Done. That's all we have to do, 2 words. So this is what I mean by interactive. It's a lot easier to do transfers to and from machines for many different files. And on top of that, you do have access to specific Linux commands that we've already talked about. You can find a whole list of them in the man page for sftp or just online in general. But basically, it allows you to, it's kind of like you go into an Amazon warehouse, let's say, where all of the packages are, and you pick and choose specifically the ones that you want, okay? Whereas scp is more like you call the Amazon warehouse and you tell them what you want. So calling them is good for 1 or 2 files, a small amount of files, whereas actually going to the warehouse and being able to pick and choose what you want is great for many files and for giving them files and retrieving files, okay? So that's sftp. Now, to exit this, you just type in exit like normal, and then we're good again. So one more way that we can transfer files in between our local machine, which is also just a server, so I'm just going to say between servers or between machines, is using rsync. Now you might be wondering, why does rsync exist? So we know scp is good for 1 or 2 single file transfers, basically simple and it's easy. SFTP is used for more like picking and choosing, and it's very interactive, so it allows you to be very efficient with your sending and retrieving files. But what about rsync? Well, rsync is the most powerful when it comes to automation, and the reason for that is because you can run batch commands using rsync. If you don't know what batch is, don't worry about that. I'm not going to go into it, but just know that it's the best for automation. Number 2 is that instead of sending and retrieving the whole file, it's only going to send and retrieve only files that changed. So only files that are different between the local machine and the remote machine, and also within those files, only the parts of the file that actually changed. So what this means is that, let's say you're transferring a 1 terabyte book between your local machine and the remote machine. What's going to happen with rsync is that instead of transferring the whole file, it's only going to transfer the specific pages that changed, which makes rsync extremely, extremely efficient and powerful. On top of this, it also supports compression of the files during the file transfer, so it even saves you on bandwidth and transmission time. All right, so now let's actually use rsync, and I also want to talk about a few other features that rsync offers that would make you want to use it. So when you're using rsync, typically you want to add these 3 flags almost all the time, and I'm going to explain them super briefly. A is for archive mode, and it's going to not only copy your file, but also the file metadata, so things like the access controls and just this other information. Z is for enabling compression, and this is zlib compression. You don't have to know what that means, just know that by compressing the file before you send it over, it's going to save you on bandwidth as well as the file transfer time, so the time that it takes to actually do the transfer. V is for verbose mode, and that's just for us to see what's going on in more details. And now we just treat it like SCP. So for example, I want to send the test file to Ubuntu and let's do this again, get the public IP, just like this, at the directory /home/Ubuntu. And again, the reason we do that is because the PWD here is /home/Ubuntu, okay? So if we try to do this, we're actually gonna get a permission denied, and that's because we haven't put in the identity file. And we know how to do this with sftp and scp, but with rsync, it's a little bit different because in rsync command, the -i actually means something different. So the way we pass in the identity file is actually by doing -e, and then we're gonna do ssh-i, and then the name of the file. So linux network.pem of the identity file, I mean. I can't type. So this, I know this is a little confusing because it's different from the other commands that we've done for file transfers, but you can read more information about why we're doing -e and what this means on the internet. I'm not going to go into it, just try to understand that this is just how you do it, and it's different from the other ones. So now if we do this, we'll see that it's actually going to send the test file, okay? And we get a little bit more information, and of special note is speed up. So just know that greater than 1 means that by using rsync, it's predicted, or it's likely that the file transfer was done faster than if you were to have used SCP or SFTP. Okay, that's all you have to really know there. All right, so let's go back to our terminal, and instead now I want to send everything in my current directory. So the way I can do that is just doing // and we'll see that it's going to send everything. I don't need a -r flag. I don't need anything. It just automatically sends everything. So Linux network, golang, gomod. So everything inside my golang directory. And yeah, this is great. So notice actually how it did not send the test. So this one right here. So I know it says test right here, but this is test.txt inside the golang directory. But what I'm talking about is test like outside in my current directory. Okay. But now if we go to Firefox and we do ls here, oops, we see that we have everything, which is great. That's what we expect. But again, it didn't send the test. Okay. So now if we try to do exactly the same rsync command, just for fun, it says sending incremental file list and nothing is sent. Okay, it didn't send anything. And that's because there was no change with all the files that we have in our local directory in comparison to all of these files. So this is the power of rsync. Now, if we do echo and we add something into the test file, just like this, and then we do the rsync command, we're going to see that the only thing that was sent was test. And as I said, this is because the only difference between our local machine and the remote machine was the test file, okay? And so it only had to send the test file over. All right, so one last feature of rsync that I want to go over, and it has a ton of features. Like if you do rsync --help, yeah, there's an insane amount of things you can do with the rsync. It's definitely the most versatile out of all the ways to transfer files to and from servers. But the one I wanted to show you is specifically for backups. So what we can do, let's see here, rsync -e, all of this. So let's do test. So we want to specifically send our current test file from a local machine into the server. And if we do this, there's been no changes, right? So sending incremental file list and nothing was sent basically. So there's no changes. That's what we expect. So let's make a change to the file. So let's just add the letter K into test. And now if we run the same file, it's going to overwrite the one that we have on the server, right? So since there was a change, it's going to copy our new file into the server. However, maybe this isn't what we want because it's going to overwrite it. What if we want to have a backup copy? And rsync can actually do this. So let's add the appropriate flags. We can do -- backup. So this is going to run rsync in backup mode. For this to work, we need a backup directory. So backup directory, I'm going to call it just backups. And suffix of the backup is going, and this is optional here, but we can add a suffix for the backup file that gets made. And I'm just going to do like, I don't know, back, okay, just like this, .back. So if we run this, now there's a change. So we're going to see test was sent over. And let's go to our server here, do an ls. We see that now we have a backups directory. So instead of completely overwriting it, what it did, in fact, let's cat test, and here we see K. So then we do have the new test file with the changes that we made. But if we do an ls into backups, we see that we have test.back, and if we cat backups test.back, there is nothing. So this was the previous version of our file, and this is the new version of our file, but at least we have a backup now. You know what I mean? So this is extremely powerful for doing backups. And rsync, you can also do backups. It doesn't have to be a remote location. Like you can do backups or use rsync in general with your local machine only. So you can do like backups from one directory to another directory in your same local machine. It's extremely powerful. And yeah, I think that's a pretty good introduction to rsync. All right, this video wouldn't be complete if we didn't talk about APIs. However, I'm only going to cover them in like one sentence, two sentences. APIs is a very complicated and deep topic. So that requires its own like whole separate series of videos. But I'm just going to show you how you can test APIs. Now, if you're not familiar with APIs, that's basically just the way that we send and receive data through the internet. And it's used like everywhere. So most likely when you're doing a Google search, like when you hit enter on the search bar, what's going on is that you're sending an HTTP request or HTTPS request to a specific API endpoint that it lives on a specific server, and that endpoint is listening on a specific port, and yeah, it's going to return a specific response based on what your request is. So in the case of Google, you hit enter and it's going to send an API request to Google search servers, at which point it's going to do whatever the API needs to do, probably do a keyword search in its databases of all the pages that might match your query, and then it's going to return the top 10 pages at a time or something. And that's the response that you get. So if all of that flew over your head, no worries. You can come back to this video once you learn more about APIs down the future. But I'm just going to show you how you can make your own requests right now, and that is through using curl. Now, we've already talked about curl a little bit, but curl is extremely powerful, and it has a ton of options that you can do. If we do help all, you'll see a very similar thing to rsync, where it just has so many options. I'm only going to show you the most used, or at least what I think is the most used and the most practical ones right now. But of course, curl is a very powerful tool. So as we've seen already, we can do a curl and do a specific server. So for example, example.com. Okay, and I'm going to do the verbose flag just so you can see what's going on when you run this. So as you can see, it's going to resolve the host name on port 80 because curl does HTTP protocol by default. And if you recall, HTTP is always bound to port 80, or is always sent to port 80. We're going to get many IPv4s and IPv6s. I'm not going to talk about IPv6, but all of these are coming from a DNS query that was sent to resolve example.com. And if you recall, we can do that. We can see this ourselves by trying the dig command, which we already did. But it's going to use that IPv6 to connect to it, okay, on port 80. And then everything using the right arrow is what we sent. Again, we've talked about this. So we're sending an HTTP request, and that's what this looks like, okay? So it does this for us without us actually having to write all of this, which is what we had to do when we used netcat, if you recall. And then this was the response. So we got a 200 status code, which I will briefly talk about in a second. And then content type, text HTML, which tells us that we're getting an HTML. Everything else kind of doesn't really matter, but here's the HTML that we're getting. And again, we get the example domain here, okay? Which is the same thing that we would get if we search this online, like example.com. Okay, so now, as you could see, it was doing a GET request. So with curl, you can actually specify which HTTP method you want to use. I'm not really going to talk about HTTP methods. So again, come back to this video once you know a little bit more about HTTP and APIs. But if you do already know, then you can specify which HTTP method you want to use by using the -x flag. And then here we can do post, we can do get, we can do delete, whatever you want. By default, curl is doing a GET request, and that's why we're able to retrieve everything, okay? So if we do get example.com, oops, it's going to do the same thing as without this flag, okay? Another thing that we can do with curl is actually pass in our own headers. So most likely, if you're making your own API and you want to test it, you're going to do something like this. So get whatever your server is, okay? So I'm going to do example.com again, just so you can see the example. And then you can use a / to do multiple lines. And then here we're going to pass in, like, for example, -h for headers. And then here we can do like content type, just like this, application /JSON, okay? Something like this, and you can keep going. And we can also specify the data, or like the body that we want to send. So in this case, it's JSON, so we can do something like name test, okay? Something just super simple like this. And yeah, so this should just work. Now, again, it's not really going to do anything with this because it doesn't, like, this particular API endpoint probably doesn't take in any data or bodies, okay? But I hope you can see what I'm trying to get at here. You can use this to test your own endpoints when you do this, okay? Now you can do the same thing with authorization JSON. So instead of doing content type, you can do authorization, or sorry, I said authorization JSON. I meant to say just bearer here. So bearer using a JSON web tokens. So that's, and the token goes here, okay? So what I'm trying to say is it's very versatile. You can use curl to test your own or other people's APIs, and you can do everything you need to do here just using curl, okay? You can also type or output this, redirect the standard output into a file like normal. You can do whatever you want with this. So very useful to do curl. One last thing I wanted to show is just if you want to get the response headers, you can just do the -i flag, example firewalls.com, and you'll see we only get the response headers, which can be useful if you're just trying to see the response codes. Now, speaking of response codes, let's talk about them just a little bit. So when you get a response, you're going to get a response code as well as some content. Now, in this case, it's not showing the content because we're using this flag, but if we do -v so we can get everything, here's the content itself that we get. We can see a content type, text, HTML, and then we still get the same information that we did here, right here, okay? So why would you want to use -i? Again, this is for testing. You can automate all of your tests to use curl -i and check if the response code is what you're expecting it to be, okay? And in fact, this is probably what a lot of testing libraries are using in the background. So yeah, that's kind of curl in a nutshell. You can do a lot of other things too. One more thing I wanted to mention with curl is that, let's say I do curl pokemon.com, and it says we get a 302, right, response, and it says the document has moved. So with curl, it's actually smart enough to automatically follow redirects with the -l flag. And now if we run this, obviously we got a request unsuccessful. I'm not sure why. I'm not Pokemon, so I don't know. But yeah, we can follow all redirects by using the -l flag, which again is pretty nice to have. There's a whole bunch of other things you can do with curl, as I said. You can just use the -help commands and see what you can do with curl. It's kind of insane. But yeah, that's curl in a nutshell. All right, so now let's actually use curl to probe some APIs, or to like send requests to APIs, okay? So there's actually a GitHub public repository that has a bunch of public and free APIs that you can use. And here I've already found one that I think is a good introduction, and that is Meowfax right here. So I opened it up on this page, and we scroll down and we see example usage. We just have to run curl https blah blah blah.com. So let's try that. So we go to our terminal, and we do this, and we get a response, which is awesome. So this is JSON, and the way I know that is because it has curly braces right here, but we can actually verify this by running the same command with -v. And now we're going to get a lot more information than usual, and that's because this is using HTTPS, which means there is some sort of encryption going on. And so there's information about the encryption that's happening, so you can read this on your own time. But if we scroll down a little bit here, the response we get, let's see, content type, application JSON right here. Okay, so it is JSON. And because it's JSON, that means that we can do something really cool. Oh, sorry, I meant to run it without the verbose. So as you can see, every time we get something different, which is pretty cool. But this is easy to read, but sometimes it's not so easy to read, okay? And I'm going to show you one example of that right now. So I happen to know that GitHub itself has an API that we can use. And if we scroll down here a little bit, we'll see HTTPS API github.com. So I'm going to take this, and I'm going to go back, and I'm going to use curl on it. So curl, just like this. And this is JSON once again, because it ends in curly brackets. Now, this isn't a rule, but it's a good guess that this is JSON. But this is pretty hard to read, right? I don't know what I'm getting here. So there's actually a tool that we can use to parse the response if it is JSON. And this tool is, I think, guaranteed to be installed in all Linux distributions, and that is JQ, or I'm pretty sure it stands for JSON query. So let's do the same thing. So I'm going to run the same command, except I'm going to pipe that into JQ. Okay? And dot is just for, this will make more sense in a second. Okay, but let's see. Now it is structured in JSON. So instead of it being like, I don't know, plain text formatting, it's now structured in actual JSON, which makes it significantly easier to navigate through. And let's say I'm only interested in, I don't know, this user URL. Okay, so I'm going to take this, and I'm going to do user URL here. And now you'll see that the only output that we get here is the output from user URL key. Okay, this is the key right here, user URL. Okay, and this is what we got. So I hope that makes sense. So now what I'm going to do is I'm actually going to run this. So curl HTTPS, and the user I want is Volke. I don't know if that's how you pronounce it, but this guy is very well known in the NeoVim world, I guess, for making NeoVim plugins. So I don't know. He's pretty cool. So again, this is actually pretty readable, but just to use JQ again, let's do this. And now we get cool formatting. So yeah, anyway, this is how you can test APIs, okay? And we already know some other flags we can use with curl, like the redirect flag and all those, follow redirects and all these sorts of things. So yeah, I think this is a good enough introduction to both JQ and curl so that you can kind of fend for yourself in the wild. All right, so the last thing I wanted to talk about in this video is firewalls. Now, you don't have to understand this 100% and you don't have to follow along, but I think just conceptually understanding what this is and how it's working is really good. So what is a firewall? So before we talk about firewalls, let's establish that for a program to talk to another system, we have to open a port, right? And this is like opening a door, right? We have the hotel, we have a friend that lives in a hotel, and if we want to send them something, we need to know their IP address and the port to send them the specific request or response, whatever it is. So this is like an entryway, and there could be malicious people that are trying to access and go through your door, okay? So there needs to be a way that we can prevent people from opening doors when we don't want to and connecting to doors that we don't want them to, okay? And by doors, I mean ports, okay? So what a firewall is like it's a security guard standing at the door, and they decide who to allow to enter and who shouldn't be allowed, okay? So basically all a firewall is doing is it's going to inspect incoming and outgoing network packets, and it's going to decide whether to allow or block them based on rules that we set, okay? So by default, Linux has a built-in firewall engine called netfilter, but yeah, and so we can control the netfilter by using a command called iptables, and it's just a system that we're able to use. I'm pretty sure all distributions of Linux use iptables, but here we see that iptables version 1.8.10 is actually installed. And we can modify our firewall rules through using iptables, but the issue is that it's a little complex. It's not very beginner friendly. It's very error prone, and as we have established, creating errors with firewalls can be a security disaster. So what people made is kind of a wrapper or a interface that we can use that's a lot simpler and easier. And now it's the recommended way to kind of interact with your firewall, which is called UFW, and this stands for uncomplicated firewall. Now, by default, this is disabled on your device, and we can enable it just by doing sudo UFW enable, just like this. Now, what's going to happen, don't actually do this right now, because what's going to happen is that when you run this command, all incoming ports are going to be by default denied. So all connections that are incoming to this machine are going to be denied by default, which includes port 22, which is what is allowing us to SSH into our server, okay? So if we were to run this right now, we would be locked out, which we don't want to do. So what I'm going to do instead is do UFW allow in port 22, all right? So again, we're just saying, okay, firewall, we're going to make a new rule, which is going to allow anything incoming on port 22, okay? So if we run this, we say rules updated. And now if we run UFW enable, this may disrupt SSH, but we already allowed it, okay, on port 22. That's why we did it. And now we see that firewall is active and enabled. So now we can run status, and we can see all of the rules that we have. So we see everything by default is going to be disabled except for port 22, which is going to be allowed from anywhere, okay? And that's because we set it explicitly somewhere up here, okay? And that's why we're still able to connect to this server. So we can actually verify that the default behavior is to block all incoming ports by running the following command. So UFW status verbose, and we see that by default, deny all incoming and allow all outgoing, okay? That's all we have to worry about with this. So now I'm going to demonstrate this by doing a netcat command. So I'm going to listen on port 80, okay? And yeah, so -L is for listen, 80 is the port, so we do this. Oh, permission denied, we need to be sudo. Okay, so now we're listening. And if we go to our terminal here, we can do netcat on this specific, let's see, this specific IP address on port 80. And let's do verbose just to see what's going on. And we get absolutely nothing. And so what's going on here, right? Even if we type in hello and we come back here, nothing is passing through. So again, by default, all incoming packets are going to be denied, okay, unless explicitly allowed. So what we're going to do is we're going to do an explicit allow. So we're going to do UFW allow in on port 80, just like this. So our rules are added. We can do sudo UFW status just to verify. There we see port 80, which is the same one for HTTP, if you remember, which is the same one that curl uses, right? Obviously, we're not going to curl, but we're going to make a TCP connection anyway on port 80. So netcat-L to listen on port 80. Here we go. Permission denied once again. I forgot. Okay, so we're in sudo, and then we're going to do the same command here. And there we go. Connection succeeded. Why? Because again, we're explicitly allowing all incoming packets on port 80. All right. And we can do the same thing, but outgoing. So right now, if we do let's do a curl to example.com, right? And this works. We do get a response. And it's not an error because we get like the example domain and all of that stuff. So as I just said, curl is running an HTTP request in the background by default. And HTTP is on port 80. So what happens if we do UFW, sudo UFW deny out, so outgoing to port 80. So now we do this, and then if we do the curl example.com again, we'll see that we're not getting anything. And let's try this again, but using a verbose flag. So it's trying to connect to the specific IP, and this is obtained through DNS, if you remember, but it's doing a connection fail. So it's actually going through all of the different DNS translations that it possibly can, and it's failing on all of them. Why? Because they're all going through port 80, and port 80 is explicitly denied outgoing. And we can verify that again by doing status, and we're denying outwards on port 80. All right, so I hope that makes sense. Again, you don't really have to understand this by yourself or like do it by yourself, but just so you know how firewalls are kind of working. And as I mentioned, this is only a UI or like a wrapper for IP tables, right? So this is actually making changes to IP tables themselves, like in the command, just like this. Okay, permission denied, sudo. So we're actually changing the underlying IP tables here. And again, you don't have to understand what's going on here. As you can see, this is a bit more complicated, but you do see that we are accepting TCP ports from anywhere. So source anywhere, TCP, HTTP. All right. So there you have it. Now, one more thing I want to mention specifically if you are on AWS, but even if you're not using AWS, I still think this is good for you to know. AWS actually has something called security groups, and security groups is like a second layer of a firewall that is checked before you even try to connect to the server, okay, to the actual instance that's running. So I'm probably going to have an image on screen here that's going to show what I'm talking about, but here's how I can demonstrate that. And if you have problems doing this demo by yourself on AWS, this might be why. So sudo ufw status, let's see what we have. So let's say I want to allow a port on port 8080, right? So I'm going to do a sudo ufw allow in 8080, all right? And then if we do the same status thing, we see that 8080 is now explicitly allowed. So we should be able to connect. So that's what we're going to do. Netcat listen on port 8080, all right? So we're now listening. I'm going to go back to my terminal and I'm going to run the same command, but on 8080. And we see that nothing is happening. Why is this the case? We've just explicitly allowed all incoming connections on port 8080. And the reason for that is because of security groups. Now I can do a whole many videos on AWS, but if you go back to your instance information, so here I was in my client, and here I'm also in my client right here. So if I go to security, and you scroll down a little bit, you'll be able to see inbound and outbound rules, which is exactly the same thing that we've been doing, except these are separate from the instance itself, okay? So here we see that the only rules or the only ports that are allowed incoming are port 80 and 22. Everything else is not allowed. And that's why even if we do the explicit allow on port 8080 here, inside the instance itself, there's another firewall, which is outside of the instance that gets hit first, that is not allowing. So it's denying all connections unless it's going to port 80 and 22. And that's why for the demo, I had to use port 80 or 22 because otherwise this would happen and that would be confusing. So yeah, that's good to know. One more thing, if you want to reset these firewall rules, what I would recommend is first to do a sudo ufw disable. There we go. So what this is going to do is it's going to allow all ports again by default, because if you remember, enabling UFW is going to deny all incoming connections unless explicitly allowed. But now we've disabled it, so there's no deny by default, okay? Of course, the thing I just explained about the inbound rules and security groups, that is a whole separate thing. But assuming you weren't on AWS, this is how you would disable it, okay? So now, if you want to reset it, all you have to do is do sudo ufw reset. This may disrupt existing SSH, but in fact it's not, because, as I said, by disabling UFW, all incoming packets are going to be enabled by default, so we don't care about this. And we see all the rules that we had are now being backed up and reset. And now if we do sudo UFW status, it says that it's inactive. I don't actually think there's a way to see the information. Yeah, you're just completely locked out here. So yeah, that's how you reset that. All right, so the last thing I wanted to do in this video is show you and walk through a demo that I've made, which is something that you might encounter in the real world, or something close to it at the very least. And I tried to make it so that it uses all of the concepts and commands and tools that we learned in this video, at least the best that I could. So without further ado, let's get started. So the setup is that we have a server at a specific IP that has an IPv4 API endpoint running on port 80, which runs a script to retrieve some book information. For some reason, clients have errors sending requests to that endpoint. So our job is to fix this and confirm that the number of retrieved books is 2. Finally, we have to download the API response to our local machine so that we can investigate it later. All right, so let's get started. So first things first, let's see if we can actually access this server, right? Because if we're going to troubleshoot it, we need to access it, we need to SSH to it. So let's see if we can do that. So since I made this server myself, I actually know the public IP address. But again, in your case, your client or whoever you're working for is most likely going to give you the IP address so that you don't have to find this out on your own. So we have this, so we can check if we can SSH into the server. And again, SSH is running on port 22. So we can just check if we can connect on port 22, and we can do this through netcat. So let's try doing that. So verbose, and I'm going to use the Z flag. Now, Z is really great for determining if we can have access to a specific server at a specific port, because instead of creating and then maintaining the connection, it's going to just check if we can create it. And if so, it's going to tell us that, and it's just going to close the connection. So it's not going to send anything through. So that's what we're going to do. So we're trying to connect to this IP at port 22, right? Because 22 is for SSH. So let's see. Okay, succeeded. So this means that the server does in fact have port 22 open, and we can access it. All right, so let's do that. So we know how to SSH. We're trying to SSH into Ubuntu. And again, your company would tell you this, or in my case, I can just check here. The username is Ubuntu, so that's who we're trying to log in as at this specific IP. Okay. And SSH uses port 22 by default, so we don't need to specify a port. But by the way, if you did, you would use the -p flag and then a port number, like 8080 here. All right. So next up, we need an identity file because we're trying to SSH into a high security server. All right. And we do have this identity file with us in my current directory, so I can just do that. Perfect. And we are in. That's great. So now if we do an ls, we can see what files we have in here. And we see we have an API endpoint. Obviously, API endpoints aren't actually written as scripts, but this is just the demo that I made. All right, so the first thing that we're told is that the API endpoint is running on port 80. So let's first check that, because they also say that clients are having errors sending requests to that endpoint. So let's find out if we are in fact listening on port 80 and if it's open on a TCP connection port. So again, we use the ss command to list all of the sockets, or sorry, all the ports that we have. And we're looking for TCP ports that are listening, and we don't want to replace the numbers as names. So we run this, and we see that, in fact, we do not have anything listening on port 80. Let's imagine that we had a super long list. So we can actually grep here for anything that has 80, and we get nothing, right? That makes sense. But if we grep for 81, there is one entry, and that is this one, okay? Just so I can show you grep here. But anyway, so there is actually nothing running on or listening on port 80, which is a problem. So let's find out what this API, where the problem is in this API. So we can do a cat of API endpoint, and we see here that we have a while loop, so this is always going to run. We're going to run a script, and then we're going to netcat listen on port 81. So this is actually incorrect. So let's go ahead and fix this to be port 80. There we go. Made the change, save and exit, and now that'll be fixed. So what we have to do is restart the API. So let me do that real quick. And again, it's just a script in my case because yeah, it's just the way this demo is, all right? But yeah, so we've restarted. And now I can run this on my local machine as well, but then I would have to do this SSH process on another terminal, so I already have it open here. So just so you know that I don't have to do this on the AWS console, all right? So now we've solved the issue of it being run on the wrong port number. So now it's running on port 80. Okay, so now let's try running curl on the server, right? So we can do a curl, let me open this up, on this public IP. And curl by default does port 80, but we can specify a specific port by also adding 80, and I'm going to do verbose, and let's see what happens. This is suspicious, right? So port 80 is doing the correct thing. Let's inspect our files. So we know what API endpoint is doing, but what about script? Let's check it out. So we have a body, we are running this command, and we are saving it inside a variable called body, and then we're going to basically printf. So this is a little more advanced, but this is a HTTP response that we are hard coding essentially, and then we're going to print the body of the response. So what all of this is doing is essentially just like setting up the response of an HTTP request so that when we curl it, we do get a response, a valid response, because because it would be an HTTP response. If we didn't have any of this, we wouldn't get a curl valid response, and I might show that at the end of this video. But anyway, so let's see if we can actually run this command. So we're just curling an endpoint here. So let's curl it inside of the server, and let's actually add the verbose flag here. Okay, nothing is happening, but that's really weird because we added the verbose flag. So let's just wait for it to do something. Okay, so as we can see, it says could not resolve host, faker API.it. So this thing about resolving host, and by the way, faker API.it is the domain, or is the server name we're trying to access here. So as we know, DNS is the one that translates and resolves host names into IPs. So this looks like a DNS error. So when a DNS query is made, it's done so through port 53, okay? So let's actually check our UFW tables to determine if we are actually allowing port 53 outgoing connections. So we can do sudo UFW status, and let's do verbose. All right, so here we go. Default is deny incoming and allow outgoing. All right, perfect. So the default is to allow outgoing, so it should allow DNS queries outwards. However, here we have an explicit deny, so deny out on port 53. Okay, so that would be the issue. So what we're going to do is we're going to instead allow out 53. So this is going to allow us to do DNS queries to the internet, basically. So by doing this, it's going to prevent us from having this issue. So DNS servers are going to be able to translate or resolve this hostname faker api.it into an IP address. All right. So now if we run this curl command, let's see what happens. Okay, there we go. So it was resolved almost immediately. And now it's trying a specific IP, but it's hanging. So we know that the request is attempting to be sent out, but we don't really know if it is actually being sent out. And if we look up here, we also see that port 443 has an explicit deny outwards. Now you might be thinking, okay, that doesn't explain why this isn't getting a response, because HTTP is on port 80 and this is 443, but we are using HTTPS, okay? So HTTP is port 80, so you would be correct. If we were using HTTP here, then this curl command would go through, but since we're using HTTPS, that corresponds to 443, and we are denying that explicitly. So once again, we have to run this allow out on 443. Perfect. So now if we run this curl command, oh, there we go. So it was able to resolve it, and then we did actually get a response back. So that's perfect. And this is the response that we're looking for. But it's kind of hard to read this response, right? So what I'm going to do is actually just pipe this into JQ so that we can get a nicer looking response back. So if we do this, oh, sorry, let me quickly turn off verbose. We don't need that anymore. All right, there we go. So now this looks great. We get a JSON response as the output, or as the response type. And yeah, this is great. So as the situation said, we need to make sure that the total number of books received was 2. So this is actually incorrect, all right? But at least we're getting a response. So let's see, again, what the script is running. And we can see that, okay, it's making a request to this domain /API/books. And then this part has to do more with specific APIs. Okay, so these are called query parameters. And we can see that one of them says quantity equals 1. So we actually want to change this to be 2 because we want 2 books. So let's change the script to have 2 books here. So quantity equals 2, just like that. And then we save it, go out, and then let's curl again, and let's see what we get. Oh, sorry, I used the same command here. So if we do quantity 2, now we'll get 2 books, perfect. And then we do get the total 2 here. Okay, so that's what we wanted. So let's see now if we can get this same response by curling from outside of the server. So what we're going to do is refresh this API endpoint so it uses the new script. All right, and then let's run this curl command. So verbose, boom, let's see what happens. So it looks like we're still hanging for some reason. And let's find out why that is. So if we go inside and check our IP tables again, or UFW status verbose, once again, it's going to deny all incoming packets by default unless explicitly allowed. And you can see here that there's no port 80, which is the default for curl, right? And we're also specifying port 80 here. So there is no port 80 rule in the allow section, okay, for the incoming packets. So what does that mean? That means it's going to be by default denied since it's incoming and it's not explicitly allowed here, okay? So what we have to do is do an explicit allow. So allow incoming on port 80 so that curl can work. So there we go. Let's try running this command once again. And perfect. Now we're actually getting a response back from outside of the server. So this is my local machine right here. All right. So this is amazing. And let's see. Again, this looks a little bit messy to me. So let's just run JQ. We see that we get a total of 2, and we can actually specify that specifically by doing .total. This has to do more with JSON parsing. I'm not going to get into it, but the basic is that we have all of these keys, right? And then one of them is called total. So if we just do dot, which is the root total, we can get just the total value, which is here 2. All right. For example, if we wanted to get ID 1 here inside data, we would have to do dot data because we want the data field, and then we want to get this ID. So this is an array now. So again, this is getting into more programming stuff. All arrays begin at the index of 0, and then we can get the ID of that one specifically, okay? So if we do this, we see that the output is 1, which is exactly what this is, just so you can see. But we're not really interested in that. We're just interested in the total number, right? Yeah, total. Okay, perfect. So the last step was to download this to our local machine, okay? So we want all of the responses, not just the total. So what we're going to do here is we're actually going to run this on our actual server. Of course, we could do it on our local machine. We could just do 80 and then like redirect that into a file. But I wanted to download it specifically for some reason, just so I can show you in this demo here. So what we're going to do is we're going to run the same curl command. So let's see, curl quantity equals 2, right? On JQ, and then we're going to output that into a file called output.json. So this might take a little bit. All right. And then we'll see output.json here. We can check the contents by doing the cat. Perfect. And it's all JSON formatted. So now what we can do is we can run the sftp to copy the file from the server. So again, we need our identity file, which is linux.pem. And then we're going to sign in as Ubuntu at this specific IP here, just like this. Perfect. And then if I ls, we're going to see the same ls in the remote server, and we do see output.json. So now to get it on my local machine, all I have to do is get output.json just like this, exit to quit, and then if we ls in my local machine, I have output.json here. All right, and we can cat that to be 100% sure, and there it is. Perfect. So we solved everything. As I said, we can do this as well, and instead just do it like demo.json, okay, just like this. And there we go. So now if we cat demo.json, we get exactly the same content, right? And it's not formatted because we didn't run JQ on it, but I hope you can understand what I'm doing here. There we go. So we don't actually have to do the file transfer in this case using sftp, but I just wanted to show you that you could do that. Great. Yeah, that's kind of all. That's the whole demo. All right. So this part is just going to be showing you how to take down all of your AWS resources so that you don't get charged any longer. So the online terminal is safe to close whenever. Then we go to this page, and we'll see that we do have a button here that says instance state. Now you just want to click on that and hit terminate. You can ignore all of this and just hit terminate at the end here, and you'll see successfully initiated termination of this instance. Now you can go to the side here to view all of your instances, and you'll see that this one is shutting down. As soon as it says shutting down, you're not going to be charged anything more. So it'll probably stay here for a little bit. You can refresh by pressing this button, but within like 12 hours, you won't see this anymore. Okay, so don't get scared if you still see it. If you had both instances here, you can select all of them by clicking this checkbox and doing instance state and terminate as well. Okay, so you can terminate both of them at the same time like that as well. Okay, and yeah, that's all you had to do. If you want to get rid of that key that you made, the identity key, all you have to do is go to key pairs down here, select your key, and then delete. Just like this, type in delete, and you're done. It's no longer there. So yeah, that's all you had to do. All right, and the last thing we have to do if you use Docker is to clean up all of our Docker resources, and we can do that by exiting both containers, just like this. And then in any pane here, in any tab, we can do docker container prune -f, and this is going to remove the containers. So we run this, and you'll get something that looks similar to this, but different hashes for sure. Next thing we can do docker network rm, and then Linux network, just like this. And then lastly, we can delete your Docker images. Again, you don't have to understand what this is, but it does take up a little bit of space on your computer. You can view them by doing Docker images, like just like this. And we'll see that we do have a Linux network image, okay? And it takes up 451 megabytes on my machine. It might be a little bit different for you, probably not. But anyway, if you do want to keep on trying out some Linux commands in Docker containers, then don't delete this. But to delete it, all you have to do is docker rmi for remove image, and then select your image ID and copy and paste it. And that's all there is to it. If you get an error when you're trying to delete your image, it just means that you have to add the -f to force it, okay? So yep, that's all. I hope this was useful to somebody. If you have any comments or suggestions for anything, improvements I can make, just let me know in the comments or somewhere else. And yeah, so with all of this, we should be ready to move on to the final video in the Practical Linux series, I'm pretty sure, which has to do with the Linux operating system. So see you then.